Hi everyone, this is Maverick Pod, the chemistry guru. Now in today's video, we want to discuss a question involving determining total pressure when mixing two gases. So the question says that I have two bulbs, R and S, are connected to a 9 dm³ vacuum chamber as shown. So we notice that bulb R contains neon. The volume is 4.0 dm³. The pressure is given 200 kilopascal. Then we have bulb S, which contains argon at 3 dm³. The pressure for argon is 400 kilopascal. The vacuum chamber volume is 9.0 dm³. If it is a vacuum, of course, there will be no gases inside this chamber at the beginning. So what will the total pressure in the vessel be when the valves are open at constant temperature? We have 4 options, A, B, C, D. Later we want to discuss which is the solution. Now the topic tested in this question is under gaseous state, and we actually can make use of the fact that when we are mixing two gases together, the total number of mole of your gas will just be the number of mole of gas in bulb R and the number of mole of gas in bulb S. So we actually can make use of the summation of the number of moles as a beginning, and then from there we try to figure out what is the final pressure. Inside the vacuum chamber, because there are no gases, so therefore there are only two sources of gases here. The number of mole of gas in R plus the number of mole of gas in S will be equals to the total number of mole. The next thing we can do is we can bring in our ideal gas equation, because we can try to rewrite number of moles in terms of pressure and volume. The ideal gas equation is PV equals to nRT, pressure times volume, is equals to number of mole multiplied by gas constant R multiplied by temperature. I'll just rearrange this in terms of number of mole. Number of mole will be equals to pressure times volume divided by gas constant R and temperature. I can sub this term, number of mole equals to PV divided by RT, back into this equation. So the number of mole of gases in R will just be pressure of R multiplied by volume of R divided by RT. The number of mole of gas in S will just be PS Vs divided by RT, and the total number of mole will just be P total V total divided by RT. And you notice, since my temperature is a constant and gas constant obviously is a constant, what I can do is I can cancel away our denominator. Then we will only be left with the numerator term. We will have this expression PRVR plus PSVS is equals to P total V total. Then all we need to do is we just need to sum in all the values. The pressure inside bulb R is 200 kilopascal. The volume for R is 4 dm³. Pressure inside bulb S is 400 kilopascal. Volume for S is 3 dm³. P total is the one that we want to determine here. V total will just be the summation of all my volume. Now in this case, we need to remember to include the volume of your chamber, because when the valves are open and the gases in R and S are allowed to fill out the entire chamber, then the total volume will be the volume for R plus the volume for my chamber plus the volume for S. We will have an equation involving total pressure. I can just solve for total pressure. Total pressure will be 125 kilopascal. So the answer to this question actually will be D, 125 kilopascal. What we can take note of is we actually don't always need to start off with using the number of moles, then convert the number of mole to PV over RT, and we cancel away the gas constant and temperature, involving the scenario where we have two gases, each with its own pressure and volume, and if the gases are allowed to mix, then what happens to the total pressure? What we can do is we can just remember this formula, P1V1 plus P2V2 equals to P total V total. So P1V1 will be the pressure and volume for gas 1, P2V2 will be the pressure and volume for gas 2, and P total V total obviously will be the pressure and the volume when the two gases are mixed. We can just memorize this expression, P1 V1 plus P2 V2 equals to P total V total, for us to answer this question very quickly. Alright, so that was the discussion involving this question, learning how to find the total pressure when we are mixing two gases. So if you have learned something useful from this video, please give me that thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.